Hi everybody, in this video we're going to talk about skewness. First, why is skewness important? The purpose of this channel is to help the audience learn all about hedge funds. This video will teach you about how to calculate skewness, which will help you determine if your data is normally distributed. You may recall that having your name data normally distributed is one of the key assumptions in the OLS regression. This is for educational purpose only and is not investment advice. By the end of this video, you will have a basic understanding of skewness, which will help you better understand the finance literature, as skewness is a variable frequently used in the finance and accounting literature. And then hopefully after more videos and more work, run your own finance research and how to calculate the skewness of your data. Watch the video until the end to make sure you have a rock solid understanding of skewness, so you know it later for your academic and professional career. And two, there will be a short quiz at the end. Please feel free to post comments with any questions or any topics you would like to see covered, and don't forget to smash the like button. In fact, this video itself was requested in the comments of the YouTube videos, so you can see we make these in response to your questions. Skewness is the third central moment of a distribution. So what does that mean? Well, it turns out that the mean is the first central moment, the variance is the second central moment, and then skewness is the third. Okay. And so visually, skewness is when the distribution is not centered around the mean. And so you can see here with PDF1, it's skewed to the right side, right? You can see this terrible drawing here that I did. But in general, it's skewed to the right side. It's not centered. It's not centered, and it's sort of weighted towards the right side of the distribution. By comparison, PDF2 is really more centered and more symmetric around the mean, right? Because the mean here is 5. It's more symmetric around the mean, whereas in PDF1, it's less symmetric and the distribution is more to the right side of the distribution. Okay. So as I said, the first central moment of the distribution is the mean, which in this case is 5. The second central moment of the distribution is the variance, which in this case is 1.5. And then the third central moment of the distribution is skewness. And so the way that we can calculate skewness is basically take the expected value of each variable and subtract off the mean and then cube it. And so you see here, when we do that, we get x1 minus 5 cubed plus x2 minus 5 cubed plus ... xn minus 5 cubed. And that gives us mu3. And then to get the full skewness number, we divide by the standard deviation and then put the standard deviation divide by the variance, which is standard deviation squared, and then put the full variance to the 3/2 the power, and that gives us the skewness. And so the question is, do you think the distribution of stock returns have a larger or smaller skewness than a normal distribution? Well, the first question and the first really thing to think about is stock price data skewed? And the answer is it's definitely skewed, right? Because not least because it's bounded on the left-hand side, right? What does that mean? It's bounded on the left-hand side. Can stock price data go all the way to 0? Like, no, right? Stock returns are basically bounded at -1, right? It can lose at most 100% of the value of the firm, but it can't lose anything further. Whereas on the right side of the firm, on the right side of the distribution, they can go way up, right? Stock price returns can go 100%, 200%, 1,000%, 10,000%, right? And so in that way, the data is skewed towards the right side of the distribution. And so given the frequent major price gains and the fact that the distribution of stock returns is bound on the left-hand side by -1, larger skewness would be a good guess, right? More skewed than the normal distribution. And then, so just a pop quiz, if stock price returns have a higher skewness than a normal distribution, which of the 4 OLS assumptions might stock price return data violate? Normality, right? It's probably true that stock price data does not follow a normal distribution. It's skewed to the right-hand side, and then we're going to see in the next video on kurtosis that it also likely has heavier tails. Anyway, I'll see you in the next video. Thank you so much for watching. And don't forget to post questions or comments in the comments, and then we'll make more videos depending on what other topics you want to see. Thanks so much.